we have to learn the symbols that we're going to use. And what's nice about PLCs is you got very few symbols. And a lot of them are basically a lot like what we will use in motor controls. I think y'all went over the electrical symbols, right? So that's the first thing we'll look at is just the electrical symbols. And then we use that to draw diagrams. And of course, the diagrams we're looking at is something referred to as ladder logic, also called relay ladder logic. A lot of people just call it ladder diagrams. So we're going to use symbols to represent different input devices and output devices. So what does a PLC do? What does computers do? Yeah, but they just don't run programs if that's all. But what does the computer do? First of all, we got to have what on inputs, and then it's going to go through, and then it's going to process that information, and then sooner or later it's going to do what? It's going to output something. And just like your phone, if your screen breaks and stops working, what good is your phone? Keyboard could be working perfect, processor could be working perfect, but you can't output anymore, right? Or if your touch screen goes out, you can't input anymore, right? You understand? So we're going to deal with different symbols that we're going to use for input devices and output devices. We're going to look at basic ladder logic diagrams, and then we're going to figure out how to take a ladder logic diagram and convert it over to a PLC logic diagram. And that's probably one of the first slabs they're going to start doing is they're going to give you the ladder logic, and then I want you to convert that over to how we would program that into a PLC. Are we okay? So relay logic is sometimes called line diagram, sometimes called relay logic diagram, or simply ladder logic or ladder diagram. We'll refer to them as relay logic diagram. Describe the ladder, and our first step in creating a program for a PLC may or may not be. A lot of people that deal with PLCs now don't go through a ladder diagram. They develop the program on the fly. But originally, when I got into computer programming, there was only one computer, and you didn't have a connection to that computer. So what you did is you would come up and you would try to write your program, but what we would come up with something called a flow chart. Because if it didn't flow through the chart, then it wouldn't run in the program. So we'd come up with a flow chart. Then after we did the flow chart, we would write the program. Then we'd take the program to somebody they call a key punch operator, and they would take the program and punch it on all these cards, because there was only one computer operator because I didn't have access to the computer. I was writing programs over here, right? You understand? And then they would take those punch cards and I would run it through the punch card reader. And then they would try to compile it over. If it didn't work, they would write down the errors and they'd send it back to me. And then I would try to correct it, and they'd repunch the cards. So it was a long, drawn-out process. So what we did is we started out with a flow chart. And the flow chart, if it didn't work, then we knew that if I tried to take all that time and write the program, right, you understand, it wouldn't work either. So originally what we did is most of your PLCs, they took diagrams that was already out there, these relay logic diagrams that was already out there, and they wanted to convert the system over to PLCs. Well, what they did is they took the diagrams and did what? And converted over. So they had to know all the symbols that was in the relay logic diagram. A lot of times now, we'll write the program and then we check to see if it's okay, and it either says an error. So most of our programs now are written on the fly because we're designing new systems instead of doing what? Modifying old systems. But we still have large motor controls or relay logic symbols that are still being converted over. And plus, when we draw the electrical connection for the PLC, we're supposed to use the symbols that we used in regular relay logic. Everybody okay? Make sense? So then after converting relay logic diagram is drawn, converted to a PLC ladder logic, also called a ladder diagram. Ladder diagrams use to program PLCs, programs to define the operations of the form basis. So what we're going to do is, the first slide we're going to do is we're going to take a old relay logic diagram and we're going to figure out how to convert it over to PLC. Program it in. Are we okay? Almost time, guys. Relay logic, we know we have a L1 and L2. And it says voltage between two rails. We call the power rails. And it says they're labeled L1 and L2. But what you're going to find out is they'll usually use a variation of this. Because if we get too many L1s and L2s, then it can get very confused. And then we'll go to lab. So this is a print that we got from U.S. Steel. We taught a class out here for them. And you can see what they're calling L1 and L2. They're not calling it L1 and L2. They're calling it PCL1 and PCL2, right? So when you get out in the industry, because if I was to come up here and look at this gray box over there and I looked at the output, it says L1, L2, L3. If I took that L1 over there and used it as L1 over here on my motor control circuit, it would burn everything up. Because that's 208 volts, 3-phase AC up there. My control devices, one of them we have runs off 26 volts. But our control circuit, if we call that L1 and L2, and this happens all the time where people, they're trying to hook up L1 and L2 and they'll take that L1, L2 off the 208 and they'll bring it over into the control circuit without going through a transformer. So normally industry is going to use variations of L1 and L2, right? Just to let you know that it's not that 3-phase L1 and L2 up there.
That does that?
Oh yeah, do it all the time in motor control. No, because Rich Raymond does what? Before you took motor controls, I have control of that key up there. I don't know if y'all see that. And I'll come up here and make checks on that, and you'd be surprised how many. That probably somebody did it in your class, where they ran that L1 and L2 directly over. Okay, guys, y'all need to make sure you pick up all your stuff. We're not coming back in here, right? Y'all understand that? And let's go down.